Hello guys, I want to welcome you back to Engineering Trends and Innovation, where we explore the cutting edge of engineering and technologies that are shaping our future. I am your host Alimami Conte, and in today's episode, we are talking about system design, on how we can master system design in building scalable, reliable, and innovative solutions. So in today's podcast, I have a guest who is a systems engineer, and he will introduce himself to you guys, and then we will pick it up from there. I want to welcome you to the Engineering Trends and Innovation, the podcast, where we explore a lot of engineering and technologies that are shaping our future. So I would like you to introduce yourself to my audience and let them know a little bit about you, but before we take it up from there.
All right, thank you very much, Ali, for having me on the podcast. It's a pleasure to be here. Like you all know, my name is Miracle Roch. I'm a systems engineer, a senior product manager, and also a management consultant. Probably has spent the best part of the last 10 years, solving problems across various industries. I first started my career as a management consultant. And one thing with management consultants is that you're primarily a problem solver. So clients come to you to say, we have some problems, either we're trying to grow, or we're trying to be more efficient, or we're trying to cut down costs, right? Different problems. And your job is to analyze what the current state is and solve that problem. And I did that for a couple years very successfully, worked both in public sector and in private sector, right? But I've always been technology inclined, all right? And as I kept solving problems for clients, I realized that I was always leaning on technology solutions to solve those problems. Most of the problems clients had, there was a technology solution that could solve it. And so naturally, I veered into technology. And so I decided to become a product manager to build technology products that will solve real world problems. And that's how I transitioned into tech. And also because management consultants, all you do really is you advise and you build and design these PowerPoint decks, and you never get to implement
it on the side.
because you're jumping to the next project, right? So I became a product manager and I started building products across Africa. Did that so well. And I asked myself again, okay, I've become a product manager. I've built market leading products. What's the next thing? How do you scale? And as I started thinking about how to scale the products that I had built, because now you're thinking, we have products that are probably being used by 35 million people. And now you want to grow to become a 100 million person product.
Yeah.
When you start thinking at that scale, you start thinking in systems.
Yeah.
And so that's how I decided, okay, I need to go get certified and trained to become a systems engineer. I became a certified systems engineering professional. And systems engineering really is everything I've told you from my days as a consultant, solving problems for one client, to building technology solutions. It's a compendium. Systems engineering really is how do you make complex systems work together and integrate in a way that it doesn't break. You start thinking as a systems engineer when you think about scale, when you're thinking beyond a singular problem, right? And I think that the problem of the world today is that we are naturally designed to think in unitary terms. But the world is not unitary. Like, we're designed to think of a problem, oh, there's a single problem, you fix the problem, and you move on. We're not designed to see things in systems, right? And so that's also the problem, because you fight the natural inclination you have to see things as a singular item, but nothing is ever singular. Everything is interconnected. That's how the world works. The sun is able to shine because the moon moves at a velocity and pace that is in alignment with that.
Yes, definitely.
So every single thing you see, even the concept of day and night, of the days and the years, it's all connected.
Yes.
So when you try to solve problems singularly without thinking in systems, you already have a bottleneck, and there's already a limit to how far you can go. And that's some of the challenges with unitary thinking and why systems thinking is super important when you build things for scale.
That is excellent. And to be honest with you is that our society is built upon systems.
Yes.
Where we have the common type of system, which is open system and
Yeah.
closed system. Whereas the open system, we actually know that our society is an open system. It's consume and give out waste.
Yes.
And we have closed system where it is recycling.
Yes.
So on that point, I would like to ask, when building scalable systems, what core principle or frameworks do you always keep in mind?
Okay. Thank you very much. That's a very good question. I think the first thing is, let's agree on what a system is. A system, most people make the mistake of thinking that a system is an element. An element is not a system, right? A system is made up of elements, interconnections, and a purpose. These are very important. And for you to work on a system, you must know what the purpose of that system is. You must know all of the interconnections that system relies on, both intrinsic and extrinsic. And then you must know all of the individual elements that make up that system. Nothing is ever standalone. So in that sense, when you already understand what a system is, you already begin to ask yourself, so the core principle is, I want to identify the elements in this system. I want to identify the interconnections. And then I want to define the purpose of the system. Every system must have a purpose. So if you're building for scale, you must have a purpose. Why? For who? When? Right? And then what are the connections? What do I need to rely on? Do I need to rely on some external connections? What's going to be feeding into my system? And what am I going to be taking out? So understanding that is also super, super important. And I think the other thing I'll talk about is, you also need to understand feedback loops.
Yep.
Every
Feedback loops.
system has a feedback cycle of information that comes into that system, changes the system by creating a snowball effect, and then information that stabilizes the system. So you need to think in terms of feedback loops. What is coming into my system, and what's going to be the effect of that? Is it going to catapult my system or stabilize my system? So it's super, super important. And then you think about, okay, what's a and then you think about reinforcing loop.
Yes.
So what else can I add to my system that makes my system stronger or weaker? So you always have to think in blocks. So first, know what your system is.
Yep.
Know what the elements of your system. Elements are the individual things that make up that system.
Definitely.
Know what the interconnections are. How are my systems connected? What are the different connections, both internal and external? And of course, what is the purpose of my system? This, I generally think, before you even think about feedback loops and all of that, I think that these are the things that are super important and that would help you in setting a good foundation before you move on.
Yes. Okay, so I would like to ask about how do we balance scalability and reliability in practice, especially when it comes to when sometimes we compromise the order?
That's another very good question. The question of scale and balancing scalability and reliability. First, we need to define what scalability is and reliability. Scalability is scalability defines the capacity of your system to grow in orders of magnitude. So, good example. Let's start with Uber. When the people that created Uber started, they started in San Francisco.
Yeah.
And I've heard the co-founder of Uber, the original co-founder, say they didn't think Uber would be this big. They thought it was just going to be a handful of people that had spare time with their cars in San Francisco.
Definitely.
So they probably designed a system for maybe 10,000 people in San Francisco.
Yeah.
Right? If you were not thinking in systems, the cloud storage, the design of your system, your ability to handle customer complaints, your ability to handle a lot of the Google API calls that you need to estimate driver distance and location distance would be limited. And so what happens is, as your system grows, you struggle to meet up with that.
Yes.
So first, when you build a system, you need to define what scale means to you. But we've seen in real life that the successful products in our time, they've never really been able to estimate how much they'll grow. Facebook didn't think they'll become a 2 billion user company. Yeah, so you can think that you're estimating for scale, but designing for scalability does not mean you design with a number in mind. No, it means that you design your system to be capable of increasing without complicating your operations. And so that's what we call a microservices architecture. You build modular architecture. And so
Modular
what that means is
yes.
all of the single elements that make up your system, they can grow on their own. So for Uber, for example, when you design that system, the driver management system is a microservice architecture on its own, such that if your drivers grow to 1 million, you can grow the capacity of that microservices architecture without affecting the rest of the system.
Perfect.
The rider system is a microservice architecture on its own, so that you can grow your riders and increase the capacity to manage that infrastructure without affecting the systems. The wallet system, payment management system, it's a service on its own, right? The map system for location is a service on its own. The rating system is a service on its own. The Uber Eats system is a service.
Definitely.
The customer service system is an architecture of its own. Now you begin to see the different elements that make up the system called Uber.
Yep.
Now the next thing is, because you've contained each of these services on their own, these services can grow without affecting the rest. And when there's a failure point, it's easy to shut down the failure point and it does not affect the whole system.
Definitely.
And I mean, you can imagine how catastrophic it will be today in this world if the Uber service were to go down. Think about so many people that would be disrupted.
Yep.
So, but today, the Uber rating system can go down, but Uber will continue to run because it's a microservice architecture that's on its own. So, I don't know if it's happened to you, but sometimes you finish a ride and you're trying to rate the driver, but it's not working.
Definitely.
But it doesn't affect the whole system because it's a microservices architecture.
Yep.
Right. So once you understand your elements and you build your elements to stand alone, then you can scale, because if you grow up to 1 million people, 10 billion people, 10 million people, you can grow the services that you need to grow.
Definitely.
Yeah. So that's one thing to think about for scale. So scalability is not to have a number in mind, because if you're really successful, you would always beat that number, right? So it's really just designing your system to accommodate either an increase or a decrease.
Yes.
So that's one. Then the second thing is defining how your systems interact with each other, because if you're setting everything as a microservices architecture to stay on their own, you need to think about this. Okay, now I have separated my systems on their own. How do I make them talk to each other?
Yes. How do I make them communicate?
Thank you. So in traditional hardware, that's where you think about the harness system, the wire harness. How do you connect everything and make sure information flows? So how do you make your systems talk to each other? And when you're designing for that, you want to also think of scenarios where there are failure points. So you think about, what are the failure points, right? What kind of interactions would my system need? What's the frequency of this interaction? How do I make sure that there's enough bandwidth for the frequency and volume of that interaction? What are the key interactions that are super, super critical? For example, we already know the rating system cannot be as critical in an Uber system as trying to find a driver and then getting on a ride. Right? So you need to have priorities, right, for what these interconnections, what these microservices are, and what these interactions would aim to achieve. Right? So I think that's that. And then the second question around reliability, that's also, again, we need to define that. What's reliability? It's really the ability of your system to continually and optimally run without downtime. So how do you build your system such that it doesn't go down? Again, it speaks to what I've said. It's building in modular terms, microservices architecture, right? So that even if there's a downtime, it's containerized. So it's also the same thing. The mistake people make, right, is that when they think of reliability, they think, oh, increase server space, oh, hire 200 customer service people. No, but you need the system in place that can allow you ramp up your customer service process when the need is, because you don't want to hire 2,000 people and there's redundancy and they're not doing their work. You want to grow as your operations grow, right? So designing in microservices terms really helps you. And I know we talk about this, and I've been talking about technology companies, but this happens in every area of your life. And that's one of the things why I like engineering. Engineering can be applied to
everything,
every area of your life.
Every area.
And you know this very well. So it's something that's as simple as marriage. You can convert your marriage. Marriage is a system.
It's a system,
What are the different elements that make up marriage? The communication between husband and wife. Interactions with family on both sides. The decision to have kids. Finances. Long-term planning. You know, how do we want to grow and deepen our life? Okay, kids. How many kids do we want to have? Which school do they want to go to? Okay, what do we want to be doing? How do we make sure that our marriage is good? These are different systems that make up a marriage. And again, you see that the marriages that last are marriages that are able to containerize things. So if you are having financial difficulties in your marriage, it does not mean the whole marriage would crash. You understand that this is something that we should contain, but we should not make it affect our sexual relationship, the time we have for kids,
Definitely.
right? And the time we just have to spend with each other. But you see that marriages that fail are marriages where they don't build in systems. So there's a problem, someone is having an issue with work, one with the husband or the wife, and they bring it home because they've not separated these different elements, and then it affects the entire thing, right?
It affects the entire
and that's why
relationship.
systems thinking is not just engineering, it's everything in life. Like
Yes.
your life is a system. You have your friends, you have your career, you have your academics, you have your faith, you have your community. These are the different elements that make up your life. And if you're not able to containerize each of these elements to allow them grow at their pace, it's always going to draw you back.
Yes.
And that's what we mean by, thinking in systems. And then thinking about scalability and reliabilities, you constantly have to always give yourself the opportunity and the chance to do more. So you have to expose yourself to knowledge so that you can grow. You have to take care of your body so you don't break down. Don't expose yourself to harmful practices so you don't fall sick. Because if you're sick, you can't do things.
Yep.
Right. So that's really how you think about things, how you think about scalability and reliability. And yeah, that's it.
That is explicitly understandable, and I actually appreciate that you are breaking the engineering side of things in relation to our daily lives, and which leads to our relationship between one another. And for you all to know that systems engineering can be applicable in our day-to-day activities based upon what you do, what you don't do, how you program yourself, and how you build upon subsets of activities in your daily life. So that one leads me towards, but we know that in every system that we build, we face challenges. So I want you to explain to my audience, let them know about what are some of the biggest challenges engineers face when designing large-scale systems.
Thank you very much. I think number one is humility. Humility is such an important trait when you're building, because when you're building, the first thing you don't want to do is limit the possibility of what you're building to what you know.
Yep.
So you have to be humble enough to get different viewpoints, right? That way you expand the possibility of what is possible.
Yep.
Right? And there's a reason why large-scale infrastructure projects, you have someone in charge of the architectural design, you have someone in charge of the structural design, you have someone in charge of the electrical wiring, you have someone in charge of the civil engineering, you have someone in charge of the health and safety design, all of that. Because when you build large-scale projects, you cannot limit it to just yourself. So but if you're not humble enough, you will not know to ask for help or to seek advice, right? So the first challenge is ego. Ego and that's something I've seen so many times in my experience. People that have ego, that are not able to set aside their ego to learn, they always run into trouble.
Yes.
That's one. Number two is, again, I'll keep coming back to this. The problem is thinking in unitary terms, not being able to think in systems. Right? That's also one of the problems at scale, because when you build for scale, the interconnections, as you go up in terms of complexity, your interconnections increase. So you need to be able to figure out what the different interconnections are. What are the different things that my system relies on? Right? How do I make this scale up? What are the challenges that I can foresee? Right? And then number three, too, is that you always have to find, one of the other challenges, the inability to find the balance between being optimistic and being pessimistic, right? So you have to think in two ways. You have to think what are going to be the problem points and what are going to be the leverage points. These are very important. So what are going to be the possible problems that I'll face as I try to build this system to scale? But what are also some of the leverage points that I can latch onto for growth? And a good example for this is something in consulting that we call macroeconomic assessment. So we call it industry and market assessment. And industry and market assessment really is where you size up the industry where you operate, because at the end of the day, you would always be subject to the general trends in any market that you play in, right? So a good example is, let's use Uber, for example. If you were the systems designer or the systems engineer in Uber, you think, what are problem points? One problem point is, oh, when people order the rides with my drivers, they can strike a relationship with the driver and then take that relationship offline. The next time they want the ride, they won't go through my app. They'll just call the driver directly and I'll miss revenue. Right? Good example. But if you think always just in problems, you would never build anything.
Yes, definitely.
You would never build anything.
Definitely.
So that's a problem point. Good job, you found that. Now you have to think leverage points. So what's a leverage point from this interaction that I can use to balance? And so that's where you have things like rating system, some sort of historical analytics where if a driver hits 10 rides on the app, they get a bonus. If they hit 200 rides, so you create an incentive system for the driver to stay on the app and not take rides off the app, because there's an incentive system and they're trying, oh, I need to hit 100 rides so that I can win this bonus, right? And then on the rider side, you think, oh, I need to keep hampering on the different safety features we have in Uber and say, oh, we have some sort of protection program. If you don't like your ride, we would always refund your money, right? So that the rider is incentivized to stay on the app because they would always want some sort of, bonus, right?
Definitely.
And so if they know that, oh, if I take this ride off the app, if anything happens, Uber is not going to save me. Yeah. So let me stay on the app so that if anything happens, Uber will give me my money back. So you see how you've balanced thinking, pessimistic thinking, and optimistic thinking. So this is a problem point, but this is also a leverage point.
Yes,
so that balance. And it's easier said than done. So many people, it's so easy. The natural human mind is so good at finding problem points. We know how to complain. Think about it. Nobody ever teaches a child how to cry.
Yes, nobody.
A newborn baby is born and the first thing they do is cry.
Cry, yes, definitely.
But they were in the womb all along and they were quiet. So you see that the human mind is naturally designed to complain and spot problems. But it's not naturally designed to see leverage points and solve those problems. You have to teach your brain how to solve those problems. And I think that if you're able to do these three things, number one, be humble. Number two, think in systems and interconnections and purpose.
Yes.
And then the last one is balance optimism with pessimism. So it's not just problem points, but what are the leverage points? And the last point that I didn't mention, and this is actually something to touch on. Purpose is very important. A lot of people live life without asking why.
Yes.
And if you must build a system to scale, the first question you should actually ask yourself is why? Why am I building this system? Why? What am I trying to solve? What is the purpose of this system? And there's something in systems design that we call POSI. It's called the purpose of a system is what it does, not what it is intended to do. So what is my system going to do? That's your purpose. The purpose of every system is what the system does. So that's actually a very important thing that will probably take us another long time to talk about. But that's super important as well.
That, I think, based upon your explanation on the various challenges that we face when we are designing a system, but because I worked as a mechanical design engineer, sometimes we face sometimes we face challenges when we are designing some complex systems, and we literally need to understand that these systems are being built upon various sets or subsets that we can easily walk away from or walk towards. So on that point, I would like to understand what key skills should aspiring engineers develop if they want to excel in the field of systems design?
Thank you very much. Number one is you need to really develop your critical thinking and analytical thinking skills. You must be able to ask yourself, what else? You must push yourself to ask yourself, what else? You cannot think in limits. Like when you see something, ask yourself, why is this thing here? What else can I add to this?
Yes.
So being able to think critically and analytically is super, super important. That's, matter of fact, I think that's the most important skill that you need to have as a systems engineer, because people are relying on you to make systems work and not break. You talked about your mechanical engineering experience.
Yes.
But a systems engineer needs to make sure that the mechanical systems work hand in hand with the electrical systems and work hand in hand with the electronic systems.
Integrated process.
Yeah. And you cannot do that if you're not trained to think critically as to why things exist.
Definitely.
And what the purpose of those things are.
Exactly.
Right? So that's super, super important. That's the first skill. The second skill, sort of similar to what I've said, is you have to be humble to learn. Yeah. You need to have a growth mindset. So the growth mindset is people are going to come for you. People are like a mechanical engineer that's been years in experience, and you tell him, no, you can't do this. He's like, who are you? And you need, because the mechanical engineer is only thinking about his mechanical system.
Mechanical system.
He doesn't care about the electronic system.
Yes, he doesn't give any consideration if that other system communicates with this other system.
Yeah.
As long as the system that is being built is
working
functional
for the
specific purpose of that field, it doesn't relate to whatever. Definitely.
So when you come and tell him, oh, no, you can't do the piston this way, because if you do it here, I won't have space to fix my battery. He's like, how is that my business? Yes. I don't need the battery.
Definitely.
But it's not his job. It's your job to think about how everything fits together. So when you have pushbacks like that, you need to be humble enough to understand their viewpoint and work with people to see your goal. So you need to be a good people person, because you need to be able to sell your vision and get people aligned to your vision. Right? So that's super, super important as a skill to have. I think the other skill to have is that you also need to be a man of, or a person of conviction. Because your job as a systems engineer is to sell a vision that nobody else is seeing. And if you're not good with being able to convince and sell an idea, you would struggle for credibility.
Definitely.
Because people are like, who is this guy? What's he saying?
Yes. Yes, definitely.
What's this guy? So you have to be a polymath of some sort. You need to know something about everything. Like you need to know about engineering,
electrical, plumbing. You need to know about architecture. Like understanding like the fundamentals that build up from each systems that makes it functional and makes it meet the demand of the customers or maybe the clients. I think I can say that every industry needs a systems engineer.
Of course.
As per your explanations. First, I was like, what are systems engineers doing? Or system designers doing? But based upon what you have explained to me and what you have analyzed on your experiences, I completely see that every industry needs a system designer or system engineer. And even household also need a system person that coordinates the household process.
I'm glad. So I'm happy I've convinced you. And
definitely.
And, let's play a little game here. Let's pick random things, and I'll show you what a systems engineer does, why you need a systems engineer everywhere. Let's pick Walmart, for example.
Yes, Walmart, yes.
Walmart, the process through which you walk into a Walmart and you pick something and you go to the till and you pay for it. It's a lot of complex elements and interconnections that go hand in hand to that. First off, someone needs to source the merchandise that is being displayed.
Yes.
The process of sourcing the merchandise cannot happen in isolation. Yes. It has to be you talking to the people in customer service and people in the market. So what do people want? What do my customers want? I remember for a Walmart, the merchandise differs location to location. There's something that people in Florida want that people in Maryland may not want.
Yes.
So your merchandise has to also be based on some sort of location intelligence, right? So you identify what your customers want. The next thing is to source that merchandise. The process of sourcing that merchandise may involve talking to manufacturers, talking to middlemen that distribute these goods. It may mean you traveling out of the US, going to China to source those things.
Yes.
Then someone needs to talk to customs because you need to clear those goods.
Yes.
And then when those goods clear, you need a central docking system where all of the inbound comes to. And then, okay, what is going to what? And then you need to coordinate the drivers when they need to come and then send things there. And then when you send it there, at the local Walmart, someone needs to inventory because you need to have unique SKUs for everything.
Yes.
So someone needs to know what is coming in. They scan it so that they know the price for it. and then they know the R where it's going to.
Yeah.
And then when you go in as a customer, someone needs to design the different directional signs so you know where to find what you want.
Yep.
And then when you pick that, you go to the till to pay. Someone needs to be able to, the system where you're paying needs to be able to have a repository of the barcode so that when they scan, they know what you've scanned. Now, none of these things will work seamlessly if you don't have a systems designer or a systems engineer thinking about all of these things work hand in hand. The logistics systems, the interconnection with that's one element. The customer service, that's another element and interconnection. And each of these systems have their own unique purpose. What is the purpose of my logistics system? I want to get goods cheaper and faster, right? What's the purpose of customer service? I want to make my customers happy so that they can come back. We've not even talked about regulation and taxes.
Yeah.
For everything you sell, the accounting system, they need to get the right taxes. Again, Walmart is in maybe all 50 states. They have 3,000 stores, 4,000 stores in the US, and maybe 10,000 across the world. Tax laws differ state by state, jurisdiction by jurisdiction.
Yes.
So the tax guys too, they need access to your sales history so they know the right taxes to apply.
Yes.
Like, it's such a complex system that would never work if you did not have a systems engineer thinking about how all these things will talk to each other seamlessly. We've done retail. Let's go to food, McDonald's. The process from which you order your burger
Yes.
to the guys in the kitchen making it, there's an interconnection there to the inventory they have, the raw materials. Because when their beef patties go down, or they don't have those buns again, or they don't have their pickles and all of those things, it triggers a system.
Yes.
So it's the systems engineer that thinks about, okay, how do I know when inventory is going low here so that I can resupply? How do I know how many staff I need to be at the till? How do I know how many people I need in the kitchen? How do I know how many minutes I can tell a customer to wait for the order? We want customers to get their order within 10 minutes. What will it take me to get this thing done in 10 minutes? What do I need? I need people in the kitchen. How do I pass the order from the guys in the till? Okay, I need a screen in the kitchen so that, okay, how do I make sure they don't mix it up? I need a numbering system so they know this is for number one and they pack it in a box and they label it number one. Oh, like all of these systems thinking. Let's go to something else outside. Let's go to a church, for example. A church is a system. How do I make my members comfortable? How do I think about what to preach about? How do I think about how to make sure that my members are well fed with the word? How do we connect if it's a church that has different branches? How do we make sure that the branches have some semblance of uniformity?
Yes.
How do we provide for our community? Just every single example we come up with, and I can ask you to give me a random example, and it's the same thing.
Yeah, definitely.
They all need a systems engineer to make all of the different moving parts work seamlessly. That's what it means to think in systems.
I think this podcast has impacted me a lot. That to be honest with you, it is playing so much deep into my intellectual abilities that I need to get another master's in systems engineering, system design. But because trust me, with such knowledge, you can't only fit it in the engineering field. It can be applicable to various different fields in the commercial industries, in our daily lives, in the law sector, the policies. So I completely understand that every organization, every industry needs a system engineer, and I am convinced. I am really convinced about that. And but with Wame, that's saying that I will want you to advise my audience or young engineers or the professionals that are looking forward to how they can implement or go into systems design or system engineering so they can scale their product and make it reliable. Let's say, example for me too, I am an entrepreneur.
Yeah.
I do my small business that I am running. So how can I basically give me some advice that I can hit a $1 million contract first thing tomorrow morning?
Thank you very much for that. The first thing is always have to ask yourself, and then what? So that's the first question I'm going to ask you. All the businesses you run, this podcast, all of your endeavors, and then what? Okay, and what? And so what? You need to be able to answer that question. Okay, and so? What's the next thing? Your ability to answer that and then what question is super, super critical. And so? And then what? So that's the first thing. And then what? The second is you need to get to the balcony, and that's just a metaphor for saying you need to go and touch grass. You need to be in the weeds.
Yes.
You cannot be recluse just by yourself and ideas will come.
Yes.
Naturally, ideas are just a compendium of the different experiences that we have. So you need to go out there and interact with things. So if you run a Walmart, for example, you need to go and see what's happening in Trader Joe's. You need to go and see what Amazon is doing.
Yep.
You know, you need to go and see what Whole Foods, Giant, all of these other guys. You cannot just stay where you are and just think that it's all going to come to you.
Definitely.
Right?
That's
so
true.
It's super important. So that's the first thing is always ask yourself, and then what? What's the next step? What's the next stage? And I must tell you this. The days are short, but the years are long.
Yes.
Sorry, no, I mixed it up. The days are long, but the years are short. And so what this means is, if you think day to day, you fall under the illusion that you have a long time. You see, 365 days seems very long,
yeah.
but one year seems short. So the days are long, but the years are short. So always think in years, because that way you can pack so much in within a short time. So always think in years. And you see that if you do that, the next question you're asking yourself is, what do I want to do in the next 2 years? Where do I want to be? As you start asking yourself that question, you start unlocking streams of inspiration. Oh, I can branch in here. 2 years from now, I can do this, I can do this. But if you go day to day, you don't even have the time to think and branch that far because you're just trying to survive. The other thing too is that you need to always think about your feedback loops. Now, and I must tell you this, a system is made up of inflow, stock, and outflow. If something goes in and it never goes out, that's not a system. So you always have to think about those loops. What's going in? What's the stock? What's the interaction and action that happens inside that box? And then what goes out? So thinking about feedback loops allows you to see things you may not even have noticed. For example, it now probably starts showing you different other businesses that you can branch out. I'm probably sure that's how Uber Eats started. Because they first looked at drivers, looked at others, and like, oh, people are ordering rides to pick up things and deliver.
Food.
And they're not in the car.
Yes.
There's probably a service there that we can offer. That's because they thought about this feedback loop. What goes in, what happens inside that box, and what goes out. So a customer makes a request, but they're not in there. They want the driver to go pick something and then deliver. So thinking in feedback loops would help. So those are the things, just to recalibrate. The first is always ask yourself, and then what? For anybody that's trying to think like a systems engineer. Ask yourself, there's always, and that question, there's nothing in this world that does not have a and then what. Even heaven and earth, there's always an and then what. And then what? So that's super important. Second is go outside and touch grass. You have to be in the weeds to understand what's going on, see what other people are doing, get to it. Don't be a recluse, because there's only a limit to how much information you know on your own. And of course, the third one is think about feedback loops. What's going into you and what's going out, and what's happening inside the system and what's going out.
That is a really good advice, and I think we can apply that in various fields, not only in the engineering sector. We can apply it in various other fields that are related on how we make decisions, how we get feedbacks, and how also we give out results. So to close this one, I would like to ask you, where do you see system design heading in the next decade, as we are seeing the rise of artificial intelligence, machine learning, and all sort of complex or human taking initiatives?
Yeah, thank you. Of course, I was going to be surprised if we did not talk about AI.
No.
Oh my God.
AI lives with us. Definitely.
So yeah, but very good question as always. Systems thinking is actually one of the fields that will be greatly helped by AI. We need to first understand that AI is a system, right? Again, what is AI? You feed a tool with a bunch of data,
Yeah.
and a natural language model goes through the data and it identifies patterns.
Yes.
Oh, based on what I have seen and know, this whenever A and B comes together, it's always A B. Like it identifies patterns, patterns, and then it answers questions based on what he knows. That you need to understand that.
Yes.
So it means that the efficacy or the ability of AI to continue to become mainstream is one, that you continue to feed it data, right? But then we've come into very advanced reasoning models because we've probably run out of data to feed AI. And so because if you keep limiting your AI to the data you feed it can't really do much. And so we're going into advanced reasoning models where the system, the AI system, can now think on its own. So you can say, because I know this is what I think. And that's why we're seeing all these deep reasoning models. That's how AI works. So you have AIs that can think on their own. And that's why people talk about artificial general intelligence and super intelligence. And it's like, oh, we might build a system that does not need the data that you feed it. It's just going to be intelligent on its own, that it can just take action. So and the risk with that is that because it did not rely on you, you can apply safeguards to it. Right, so in that sense, how would AI help here? I think that AI, because of all the things I've talked about, is actually a very good systems thinker because it's been fed data from different things.
From different sources.
So it has the ability to think through all of those things to say, how do these things work together? And I think that every systems engineer should embrace AI instead of run away from it. Because AI can help you think about things that you have not thought about before. Right? And I think that it's going to be good for the industry. It's going to be good because AI, naturally, AI is a systems thinker, right? And so if you rely on AI for your day-to-day job, you slowly start thinking in systems because AI is going to think about things that you've not thought about. So you can say things like, oh, I want to travel from here to wherever. What do I need? You're probably thinking, I just need to pack a few clothes. But AI is going to say, oh, how are you going to get there? Do you want to drive? Okay, if you want to drive, have you checked your car? You need to make sure that your car is okay. Have you checked the weather for what that day is going to be? So AI will ask you for the day. AI naturally will go and check the weather for that day. Oh, the weather is going to be cloudy. Okay, do you have enough food? Oh, there are food stops along the way. That's naturally the kind of thing an AI will do for you. So if you continue to rely on AI, it gives you the product of systems thinking because it thinks about everything. It thinks about things holistically, not in unitary terms. Now, but the challenge is you cannot rely on AI to do all your thinking for you. So as a systems engineer, you can use AI to think through things that you're missing out on. But I hope that you're learning. As AI continues to help you, I hope that you're learning and that you can begin to naturally also think about things in systems. So that's on one hand. On the other hand is that I think that as we see more prolific AI tools being developed, it might actually eliminate the need for a systems engineer because you can just have systems that do all the especially in traditional industries
that connect every
and
source.
It will simulate your harnessing system and tell you how the engineering and the mechanical and the communication systems will work hand in hand. But we're probably very far away from it. Maybe another 20 to 30 years.
Okay, so meaning that I should take back with my statement on that I need to get another master's in systems engineering and then become an AI model developer?
No, but the challenge with that though is that AI was built by human beings.
Yes, definitely.
So you need to also understand, because remember, if you don't know how to ask the right questions, your AI cannot give you the right answers.
Definitely.
So getting educated in systems engineering is not really just about, it's about being able to shift your paradigm to start thinking in systems.
Okay.
Because like we said at the beginning, the human mind naturally thinks in unitary modular terms. You think about a problem, oh, I'm hungry, I need to eat. You never ask yourself, why do I feel hungry? What kind of food do I need? What does my body need? What kind of hunger am I feeling? Is it really deep-seated hunger or is it fleeting? No, your own is, I just need to eat, right? So that's how we're built. So systems thinking, and I think there's some books I can recommend. One of the books would be Thinking in Systems by Donella Meadows.
Okay.
It's such an important book that just helps you see that everything around you is a system.
It's built upon a system.
And you know, there's nothing around us today that was not the result of someone's passion.
Yeah.
Like someone woke up one day and said, how do I build a sound system that can amplify sound?
Yes.
And that's how innovation started into what we have as a microphone today.
Microphone, yeah, definitely.
And someone else said, how do I build a system that can capture people talking and then I can put it somewhere on the internet for people to watch? But that's not how we started. First started with, how do I build this and put it on a cassette? Mm-hmm. And how do I build a player where I can watch that?
Watch that, yeah.
So, and then you see, so that's why I tell people, innovation is not a zero-sum game.
Yep.
Do you understand what I mean? You cannot always be thinking, oh, I need to do that big thing. You start with the small thing that you have, and it coalesces, and it grows, and it grows, and it grows, and it grows. That's really, and so that's why even with AI, you have to apply the same thing. You cannot just come and say, oh, AI is coming for all our jobs.
Yeah.
The first question you need to ask yourself is why, and then what? So what can AI do? And so to answer your question, it's going to be very industry specific.
Yes.
Like it's industry by industry. In traditional industries like aviation and defense, you can use AI to maybe enhance safety records, to design systems that are not too complex, you know, reduce your harness and wires, reduce the touch points between things so that it's just more seamless. AI can help you think through things that you can't think about, you know, but you need to be able to guide that process, you know. And then in traditional industries like we talked about Walmart and retail, AI can help you fast track that. It can help you with your routes management systems, and at the end of the day, you want to get goods from point A to point B as fast as possible and with the lowest cost. So you just have to ask yourself, what industry am I in? What kind of things do I want to do? What can AI do there? And then what? And that's where you come in as a systems thinker. Okay, this, right? So that's really it. I'm sorry that I'm not alarmist and I'm like, oh, AI is going to destroy everything. No, AI.
Definitely.
AI is just going to help us do things in a better way and get access to information faster than the human brain would naturally do that. Yeah.
Sure. So actually, this was a really interesting episode, and it's enlighten even me and my audience on system design that can be applicable in our various sectors in terms of our daily lives, but because we all have a purpose. Every day we wake up, we have a purpose. And even our creator have a purpose for us. So if he doesn't have a purpose for us to live tomorrow, we are going to pass out tonight. So I think we have come to the end of this session, and it is a really amazing opportunity for you to stop by and give your knowledge, your understanding, and share your experiences with me and my audience, and we appreciate you a lot, and we will continue to build on maybe the foundation that you have shared with us. So guys, I want to thank you all for listening to Engineering Trend and Innovation, with the podcast where we bring engineering and innovation that are transforming our society. So until next time, please keep innovating and keep linking your daily lives as a systems engineers. You should not go to engineering school to maybe become a system thinker. As you overheard from my guest, you don't need to be an engineer to design a system. You can easily design a system even in your household. You can design a system in your marriage. You can design a system in the way you eat. You can design a system the way you sleep. So everything, it is interconnected.
Look at that.
And please don't forget to like, share, subscribe, and also if you would like to partner or to collaborate with us, please follow us on our social platform and then reach out. We will build reliable and scalable systems as of today. Thank you very much. I appreciate you, and we also appreciate you for sharing your knowledge and experience.
Yeah, and thank you very much for having me, and it's a good platform that you have here. I enjoyed my time as well.
Thank you very much.